Hey guys, so we are ready to start day two. And here you can see the two different things we're definitely going to be working on today, which is the first derivative test and candidates test. So these are two big things. We're going to be trying to find absolute and relative extrema. Yeah. Okay, so that's what is going to be our goal today. Okay, so first thing we're going to talk about is a critical number. And critical numbers are anywhere we think that an absolute extrema or relative extrema could be. So critical numbers could actually occur like right here where we are not differentiable. So it's where the first derivative does not exist, or they could occur where we are differentiable, but we've got like a little hump, that horizontal tangent, so the first derivative would be 0. So when I'm trying to find critical numbers, then I need to look for both of these. Okay? So this is for relative extrema. Now, if I'm also looking for absolute extrema, then I include the endpoints as well. But if I just want to look for relative extrema, then I only have these two things. Okay? So absolute, you're also going to have endpoints, which we will get to. Okay, so looking at this, here is my function for f of x. What are all my critical numbers? Well, when x is -5, that would be a critical number because I have a horizontal tangent. When x is -3, that would be a critical number because I am not differentiable. Here I have another critical number at -1 because I have a horizontal tangent. And another critical number at 4 because I have a horizontal tangent. Now, later, these endpoints will start to go with critical numbers for absolute extrema. And those are kind of like in a candidates test, okay? And so we are not including these. Remember, endpoints cannot be relative extrema. So I have 1, 2, 3, 4 critical numbers for my relative extrema. Okay? So for absolute extrema, I'm going to do what we just did, but I'm going to add on the endpoints. So this is usually when I have this closed interval, and up here is typically when I have an open interval because I can't get endpoints, okay? So when I have a closed interval, then life is so much easier, okay? I'm going to go get all of my candidates. So I have where f prime is 0, where f prime doesn't exist, and my endpoints. So I've got to go get all my candidates, and then I'm going to go put them in to the original function. So I'm going to put all these candidates all here, and I go plug them into the original function, and I get some outputs. The smallest output is the absolute min. The largest output is the absolute max. So nothing too crazy. It's kind of nice and convenient of what we're doing. Okay? All right, so let's go do this next one. Just part A from the 2007 exam. A particle moves along the x-axis with this as its position. And we're only looking on this closed interval from 0 to 2 pi. Find a time at which the particle is farthest to the left. Well, farthest to the left when I am moving along an x-axis means the absolute minimum. That's what this is asking me for. Okay, so I need to take the first derivative. So pause, you take this first derivative and then pause and make sure you get the same thing. So the first times the derivative of the second plus the second times the derivative of the first. And I'm going to go ahead and factor this. And we are looking for where this is 0 or D and E. Well, let's first start, since we have these two things being multiplied, we can use our zero product property from algebra and say, will this ever equal 0 or D and E? So I have this exponential, it's not growth, but going decay. But no, it will never equal 0. We've got that horizontal axis or asymptote, and it will never equal Z and E. So there are none here. So what about this cosine minus sine? Well, I know I'm looking for where cosine equals sine, and we have talked about this on the unit circle. Okay, where they equal is on that line, y equals x. So where are those values? There's going to be two of them within this circle. That is at pi over 4 and 5 pi over 4. And there's no place where this doesn't exist. There's no asymptotes or anything. So we have a couple of critical numbers from here. But we also want to check with the candidates. So all candidates now would be the endpoints as well as those critical numbers. Okay, so we're going to go do the candidates test. So we're going to take our t and our original function, which was x of t, and plug in all of those values. And I want you to pause me. I want you to go plug them into the original and see what you get. See if you agree with me. Okay, so for 0 and 2 pi, when I plugged them in, I got 0. At pi over 4, I got a positive radical 2 over 2 times e to the pi over 4. Sorry, that's a negative pi over 4. And when I plugged in 5 pi over 4, I got a negative square root of 2 over 2 times e to the negative 5 pi over 4. So even though this is a negative, remember, it's still a positive answer. It's just a decaying kind of thing. So that answer is greater than 0 because it's a positive times a positive. And this answer is less than 0 because it's a negative times a positive. Make sure you're doing that without a calculator, okay? This is on the non-calculator. So if I'm to look for the absolute minimum, it has to happen right here. This would have been an absolute max because it was the biggest output of all of them. So we are furthest to the left. Did it want the farthest value or just where we are? It wants the time, the t. Okay, so we are farthest to the left. So make sure we know which one it's asking for, the t value or the output value. Farthest to the left at t equals 5 pi over 4. Okay? And that is your justification of working through all of that. All right, day 2.